Hi, this is Mr. Warski, and this is the fourth and last screencast in genetics. This should not take that long. We don't have that much to cover. We're going to first talk about pedigrees. Now, pedigrees are family trees, not top of the dog food, family trees, and they will trace genetic anomalies through populations. We are going to go through pedigrees in class, and we're going to practice those things as part of our activity. But you're going to have to know the symbols. So here are the symbols of pedigrees. I want you to draw these things down. Okay? And we will talk about them when we do the pedigrees. So make sure you pause this and get down these symbols. Polygenic traits is something else we're going to do in class. Now, these are traits that are controlled by more than one pair of genes. So this provides us with a huge amount of variation. Anything that deals with size, shape, and color are polygenic traits. They're quantitative traits. Okay, so we have large numbers. So they do the height thing here, right? And we get something almost like a perfect bell curve in this population of individuals due to height. Polygenic traits. And linkage. So many genes are found on the same chromosomes, and since they're found on the same chromosomes, they don't follow the laws of segregation and independent assortment. So the Mendelian ratios of 1 to 1 to 1 to 1 to 1 to 1 or 3 to 1 or 9 to 3 to 3 to 1 don't apply here. So we're going to have to figure out first if the Mendelian ratios are followed, and if not, we're going to have to map out the chromosomes so that we can show how close these chromosomes are, that they're linked. Okay? So let's talk about how we can calculate how close these things are on a chromosome. And you might have to pause these things as we go through, and we'll do these things in class too, many, many times. So first step is you're going to have to determine if it's a 1 to 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 1 ratio, and you're going to use the chi-square test to do that. 2, you're going to determine the parental crosses, which are the most common. 3, you're going to determine the double crossover. So crossing over happens twice in these chromosomes, and that doesn't happen that often. So these are the least common. Remember, we're going to practice, but you need to get these steps down first. 4, you're going to compare, and the gene that's different is the gene that's in the middle, so you're going to put the genes in the correct order. Step 5, you're going to determine the single crossover types, and we're going to do that through diagrams, but determine the single crossover. That's what SCO, single crossover. Calculate the gene distance in region 1. Don't forget to add the double crossovers. Calculate the gene distance in region 2, and don't forget to add the double crossovers. This might mean nothing to you now, but it will shortly. And diagram the chromosome with the gene map unit distances. Okay, that is it for genetics. We will practice this, and you can ask me all sorts of questions when we get in class. Have a good night.